Hello everyone, welcome to my YouTube channel, and the question for today is count binary substrings. So the statement over here is that given a string S, count the number of non-empty contiguous substrings that have the same number of zeros and ones. Alright, so given a string S, we have to count the number of non-empty contiguous substrings that have the same number of zeros and ones. The numbers they should be the same, and all the zeros and all the ones in these strings are grouped consecutively. That means that, see, if there are two zeros, then two ones, then two zeros, then two ones, 1 0 1 1 1 0 1 1. All right, I hope that's clear. What does it mean by that? All right, so there are two things. All right, so the two things given over here at that the same number of zeros and one, that is 0 0 1 1. All right, and the second condition is, and zeros and all the ones in these strings are grouped consecutively. So it is consecutive because it's not like that here is 0 0 and like that. It's not like 0 0 1 1, not like that. It isn't a valid pair, but this is a valid pair. All right, the same number as well as they are grouped consecutively. All right, I hope both the points in the problem statement are clear. And substrings that occur multiple times are counted the number of times they occur. All right, so multiple times they occur. So I hope the question statement is clear to everyone. And yeah, so by the reading the statement, how we are going to approach this problem, let's see. So one condition we'll keep in mind is the count. All right, so while driving the approach, we will keep that we have to count in the count number of 0 1, and also they have to be consecutive. All right, so yeah, we have to devise such like that. All right, our algorithm like that. Okay, so yeah, that's the thing. And the second thing we'll also be keeping in mind. All right, now let's see the example that is given to us over here. So in this example, 0 0 1 1 0 0 1 1, so there are 6 substrings that he means that have equal zeros and equal ones. All right, so number 1, okay, and I think it's not scrolling. Okay, so we have over here yeah, so 0 0 1 1 0 0 1 1. I hope that's the example. Okay, so yeah, this is the first one, and then 0 1, that is this equal number of 0 1 and consecutive. Then it is this one 11 0 0, then again this one. All right, and then 0 0 1 1 and the last 0 1. All right, I hope that's clear how the number 6 has occurred. And yeah, I hope this example is clear. Let's move on to the another example. 1 0 1 0 1. So all right, equal, the first should be that the equal number and the consecutive. So equal number and consecutive, equal number and consecutive, equal number and consecutive, equal number and consecutive. So that gives us 1 2 3 and 4. I hope that example is clear as well. All right, and the length of the string would be from 1 to 50,000, and it will only contain 0 and 1. So if it's only contains 0 and 1, then after 0 it would be 1 only. All right, so I hope that's also clear. One transition is always there. All right, because 0 to 1 1 to 0. All right, I hope that's clear. And the length would be from 1 to 50,000, so it can't be null, and it can be a singular as well, but that's the case that only a single number can be present. So in that case we will return 0, I think. Yeah, so that's the test case. So these kind of the corner cases that I always talk about, and we should always keep in mind while solving the question. If you're solving it in an interview, you must ask the interviewer about this test case, that when a single is passed, what would be the output. Obviously it would be 0, but you have to ask him. It shows that you know how to tackle the problem, how to read the problem, and how to know it very well. My main focus is on this part only, always. I know the question is important as well, but this part is very, very important. All right, the moment you started figuring out the question from the constraints given to us, then half of the problems would be solved very, very easily. All right, so I hope that's also clear. And yeah, now let's see how we are going to solve this problem. All right, so yeah, that's the question, and let's see how we are going to solve this example. All right, so the first thing given to us in the question is the count. All right, let's maintain the count. So that is 2, two zeros. We don't know that this 0 1, so we'll take it 2, because either it will be 0. If it's not 0, then it would be 1. So alright, then it would be 3, then it will again 2 1s, then again it would be 2 zeros, and then it would be 2 1s. Alright, I hope this is clear how we are going to make this problem, this thing, okay, out of this. Alright, that example is all. Let's take this example over here and try to revise the approach. Alright, because that's a simple one, and I think most of you will find it difficult as well. So let's count 2, 3, then sorry, I have mistakenly 4, and these are 3 and 3 6. So this we will be getting from here. Alright, I hope that's clear how we are performing the count operation, because we are looking for the similar, and as soon as it changes we reset the count and we count. Alright, by this we can have the groups. So this is called grouping them. Alright, either it will be 0 or it will be 1, because we are given that's in the question. Alright, now we have grouped them to know that how many 1s and 2s are occurring. Alright, so yeah, now if we are going to make a pair between these two, how we will be making? One pair would be this, alright, and another pair would be this. Alright, so how we can get this from? So this is 2, alright, and this is also 2. This means that when they are consecutive, by grouping we will look for the minimum number. So the minimum is 2, we kept 2. Alright, now let's see for this case. Alright, 0 0 0 and 1 1 1. So these are 3 4. The minimum is 3. Let's say 3, and now let's see how 3 1 2 2 and 1. Alright, so I hope that approach is clear, because either it would be 0 or 1, and by grouping them we can have the answer. Alright, now I think the approach is pretty much clear to everyone. Anyone can solve it on their own as well. So now let's see, because 3, then minimum of these two would be 3, and minimum of these two would be 4. 4 plus 2 6, 6 plus 3 9. 9 is the answer. Alright, I hope that's clear. We just followed the question. We first counted like this, and then see, then if these are the two pairs, then how number of pairs can be found? So 2, that is the minimum number that is the present when comparing the two groups. Alright, I hope that's clear. The approach is clear to everyone. It's a very simple approach, and I have literally told the steps to how to calculate this approach. Now let's apply this approach to the example that is given to us over here. So that is 2, 2 and 2. Alright, so what is the minimum of these two? That is 2 plus minimum of these two 2, and minimum of these two 2. So 2 plus 2 4, 4 plus 2 6, and the 6 was the answer of that example. I hope both the examples are clear. I have taken a different example to get the logic clear into the mind, and now it's just the coding part. Alright, the approach here was very important, and how we get to it was also very important, because we just followed the things that were given in the question. There was nothing like minimum, maximum we have to find. So there was no dynamic programming, or like we have to remember the results and all that stuff. We just have to group the data. That is, we have to count the number of zeros and ones, and then we have to think how we are going to devise our algorithm. Alright, and it's done. And if you are still facing any kind of difficulty in this, then I think after seeing the code for this problem, everything would be clear. I hope this approach is clear to everyone. Now let's see the code for this problem, and let's just solve. So yeah, here is the code that I have written it. Basically I have taken groups. Alright, and yeah, and t is equals to 0. Alright, so t would be giving me the count as well. So what will the found, because it can't be like the groups array would be formed completely when they are 0 1 0 1 0 1. Alright, everyone is distinct. Alright, so that's why I have taken from the maximum length could be s dot length, and minimum could be 0 as 1 as well, because if there is a singular number only, then it's length. Okay, so this is just a mathematical part. That is how we are driving the groups array. It could be of any length. Alright, and the maximum length would be obviously the size that is given to us, in which all the elements are unique. I hope that's one is clear. Now this is our main algorithm. Here we are just filling the values in the group array. Alright, so if the count, we are incrementing because we are now receive the not equal value, and if the value is equal, we just increment that value where we at. Alright, after that we know that it is filled up to t locations, so we have to look further. Alright, if we look further as well, what will do? It will just zeros only. So minimum would be 0, and anything adding to 0 would give the result 0 as well. So I think that won't be the case necessary. So now let's just we just calculate the minimum and keep on adding to the answer. Alright, yeah, it would give an error when there's the 2, 3, 4, 6 we divide. So its minimum is 2, the minimum is 3, and the minimum is 4. So if there is 0, then also the minimum would be 0 only. So if we drive it to end also, it won't matter. And I hope that's clear. You can drive it from t to anywhere. I've written t to just simplify the algorithm to know that where the last value stands. All right. So that the location of the last value. All right. I hope the code is clear to you as well. Now let's try to submit it. As you can see, it's accepted. So if you have still facing any kind of difficulty, please feel free to reach me out in the comment section. I'll surely reply to each and every one of you. And yeah, please, if you like this video, please press the like button and share it among your friends as well. And please subscribe to my YouTube channel. Thank you for watching. Bye bye.